Welcome to this video. We're going to be talking about reflections. Let's get started. So in mathematics, a reflection is the transformation of a pre-image, which is the before, onto an image, which is after, by mirroring across a line of reflection. So you can see in this example here would be your pre-image, and then afterwards reflected down here onto your image. So in order to describe a reflection, we need only to know the equation of the line that we're reflecting over. So we're going to deal with four major cases: reflection over the y-axis, reflection over the x-axis, reflection over the line y equals x, reflection over the line y equals negative x, and we're going to talk about each of these in detail. So the first two cases, reflection over the x-axis and reflection over the y-axis, let's talk about those. So here you see the shape or the point is reflecting over the x-axis. So we can write that as xy goes to x negative y. Notice the only thing that changes, they don't flip places, only the y coordinate changes sign. So that's a reflection of the x-axis. Reflection of the y-axis going the other direction, you can see that the only thing that changes is the x coordinate. If it was negative, it would turn positive. If it was positive, it would turn negative. So only the x coordinate changes. So if you noticed, it's actually backwards. So the coordinate that changes is opposite of the axis. So keep that in mind. So reflection case 3 and 4 are reflection over the line y equals x and over the line y equals negative x. So over the line y equals x is a diagonal line. It has a positive slope. And you'll notice that the coordinates actually flip places. So they won't change signs. If they're negative, they stay negative. If they're positive, they stay positive. They only flip places. And a reflection of the line y equals negative x is going in the other direction. Notice that they flip places and they change signs. So if it's y equals negative x, they flip places and change signs. If it's just y equals x, they just flip places. But suppose you're given the reflection of a shape and you actually want to determine what is the line that it was reflected over. How do you accomplish that? So here's a situation where you've got a shape that's been reflected and you want to figure out what line was it reflected over. So if you connect all of the transformed points, so the pre-image and the image after transformation, you get these dotted lines. So I'm connecting all of the like points, and then what I'm going to do is find the midpoint of each of those dotted line segments, and notice they all line up. Well, that's because the distance from the reflected image from here to the reflection point is going to be the same as the distance from here to here. That's why all the points line up. So we can draw a line that passes through them. And we can find the equation of the line by looking at the graph. First, we write the slope of the dotted lines, and the slope of the center line is going to be perpendicular to that one. So in this case, -1, perpendicular to that is +1. Find the y-intercept by looking at the graph. You can notice it crosses the graph right at +1, so that's my y-intercept. And then I can write the equation, y equals x plus 1. Alright, that's it for this video. Go ahead now and try some practice on your own.